topic is actually the insider threat detection, and I am leveraging the AWS resources like OpenSearch and Bedrock. And little bit disclaimer here is that since a lot of insider threat companies are here, and I also work for one of them, so it is nothing to sharing the company information. It is more of my research, just a small disclaimer. And this system is more geared towards AWS environment. So if anybody is already in the AWS, they are planning to go with the insider threat detection. They can leverage these two resources, the Bedrock and OpenSearch, for their investigation. So the challenge over here is that, like by the traditional search, we can do some search. We can bring in the OpenSearch, also do the full text search and other search. But still, for doing the full search capability, we need the semantic search for insider threat. So that's the point here, like how we can leverage the Bedrock and AWS OpenSearch for doing the insider threat detection. And then I'll come over to the architecture of that, and then a demo, and then Q&A after that. So the challenge here is that if you see here, that we are using if we are trying to find car, right? And it is an automobile. So if you use automobile in our search, it will not find the car because it is not exactly matching and not even fuzzy match, it will not be able to find it. But if you use a vector search, then it will bring it up because that's how the vector databases are built. So that's one key point to know. And even if in the OpenSearch that we have before, we do the TF-IDF, like actually the architecture by which the OpenSearch works. Still it will not work, but if we use the OpenSearch vector database embedding, then it will work for us, because then we can have the semantic context over there and we can search for it. On top of that also, we can leverage the semantic search for the images, audios, and other kind of data to search, unstructured data. So how you are doing the behavioral search? So normally, if insider threat we want to find out, you try in the old way, we have some rules. And that rule is, for example, it is trying to find out if somebody downloading more than 1 GB of data in the system, then it will immediately capture by that rule that, okay, somebody is doing something bad, and then that goes to the audit trail, and we can find out that somebody is doing something bad. But if it is somebody is not doing as a 1 GB, but he is doing like 200 MB, then 100 MB, abruptly, not regularly also. So then the rule base is not able to capture it because I have a defined rule. But if I bring in the historical concept of it, like I have the old data, old pattern of the users, then I can see that, okay, this guy 200 GB today, immediately after 2 days, he does another 200 GB. So we see a pattern. We see a deviation from his regular usage. So suppose he is going to leave the company in 2 months, and he wants to take out like about 300 GB of data. He can do a little bit chunk, and then at the end of the day, he is done with his data and is gone. So when I see the historical pattern of the data and how he is moving the data, we see a deviation. And by that, we can capture that he is doing something wrong. But the thing here is that he is planning to leave in 2 months. But by the rate the standard deviation is going, it may exceed the 2 months. And I may not get the exact triggering point of my threshold by that time. But if I do it every week, like what is the deviation pattern coming, and by that at least we can show some anomaly happening to the management instead of waiting till the end or just waiting for the rule-based system. So that's what I want to bring here, that the historical data is very important. And now what I'm doing in the historical data is that if you go to this slide, if you see on the top layer, what I'm doing is that every time I have the data, I am using some prefect or Airflow kind of a system to get the data from my system and vectorizing the field. So for example, if my data has multiple fields like this, I have the event details, from which user it is happening, from which device it is coming, and then the location and all the other fields are there, right? So I don't need to vectorize all of the fields. I can just go and create the event details. So here if you see, I am going with the event details as well as the user ID. So whether it is a good idea to embed the event details along with other fields or just the event details is fair enough. So, but the main point is that event details is the most important thing that we need to embed. And then when I search by exfiltration, I can bring any kind of exfiltration that happened in the system. So all your other data in the OpenSearch can stay in the OpenSearch fields, and you can, along with that, you can vectorize this particular field. So I'm coming to the point like what are the other fields we can embed along with the event, so which has more meaning to this context. Okay, so now let me go back. So why there is two different flow? So first flow on the top is that when I'm starting my system, I don't have the historical context. So what I'm doing here is that I'm taking the data every night it is running and getting the chunk and then embedding it and pushing it into the system. So if I do it for 3 months or 6 months, I have built my historical pattern for the users. It will miss some of the cases, like for example, a new user joining, his data will be not that enriched, right? He may be a few weeks of data, but still it is okay for all the other employees, right? So for each of the employees, it is embedded this system in their laptop and it is running as root. So it is capturing whatever events he is doing. So the first pattern is that is periodic run to enrich the historical data. So it will run for 6 months, and on the 181 days, it is going to delete the old one and create the new one. So sliding window it is going. The next one is that if I'm going to search for a particular problem, like for example, find exfiltration for this particular department, then it will bring like for that year, whatever exfiltration happened, or for a particular month. I am coming to the demo for that. So this is the basically a RAG pipeline, which is actually getting the user input, creating the vector embedding, and then it is trying to search that particular thing in the vector DB, and then giving the user input, whether it is bad, anything bad, based on the risk score. So if I go to the next diagram, yes. So here it is like we are doing the approximate nearest neighbor search, and then we have the rules, static rules, to find out if anything bad, and we can have the ML model also. And then we have a baseline for that user, what he is supposed to do. And we compare these things and we define the risk score. And we have a threshold for the risk score. If it reaches that threshold, then definitely there is something wrong going on. And here is who, because everybody is not working on the insider thread, right? So here are some examples to make you familiar with that system. So for example, the data exfiltration, right? Somebody is downloading 15 GB, but the company's limit is 1 GB. So definitely it is kind of a problem. And here I don't have to see the historical data. I can upfront say that, okay, this is a problem. Similarly, if we go to this one, like admin accessed 340 EC2 instances in one session. So here, there may be a rule here already defined that he can access 4 to 5 instances, but this is definitely a higher number. So we can check the static rules as well as the historical behavior for that whole group, which group he is working on. Maybe he's on some special project, or the whole US, all the EC2 instances are down or something happened. He is given that privilege to do that. But as a system, when I'm running, I don't know like whether he is in special project or not. So I can flag this event and then let the admin decide that whether they want to mark it okay or they want to stop the user from the accessing the events. So similarly, if you see here also, somebody suddenly log in from New York. So it is definitely either his account is hacked or he went to New York. So if he has gone to New York, then the system is updated by his manager. So it will go through, but definitely it is a anomaly. And I have a historical event that he is always logging from Santa Clara. So I can definitely from historical behavior, I can flag it. So always if you see here, the historical data is helping here. And when we do the search on the historical data, if it is a semantic based search on a vector DB, then it's definitely helping it. Because if somebody is copying something, if you copy something to S3, the possibility of finding the data is much reduced, but if we just search by the exfiltration, we get all the data. So by that way, the cosine similarity if we use for the vector database, it has a broader scope of catching the events. So I'm coming down because when you get a broader scope, you get more data. Now we get also confused when you get more information, right? So I'm coming to the point that how you actually mitigate that problem. So here actually, if you see that I'm putting the employee ID, but whether it is really helpful or not. So the next problem, if you see here, I have two different events, describe trail and another one is the delete trail. So now semantically, if you see, when you are doing in the OpenSearch is not made for insider thread. OpenSearch is a general database, right? So now by seeing these two data, it will not treat them so much different. So what we can do is that when you are doing the embedding, we are adding in the category along with it. So one is the evasion, another one is the config read. So when we add that one with the actual event, it actually carries more sense. So instead of padding in the user ID for the event, if we pad in the category and all of the relevant fields, then it carries more weightage. And then when you are searching it, the possibility of getting it is much higher. So this embedding is really important part when you are doing any vector search. And if you go to this slide, you will see here that we are doing the embedding query, vector search, and returning the top K, right? So here, if you go to the stage 2, if you see here that metadata filtration is here. So what are the metadata? For example, I have the event details, I have the user ID, I have the device, I have the geolocations. So all the other fields which is relevant for my search, I can keep them as a metadata. So we can do a broader search, bring in a lot of the users, and then you can do the filtration on the metadata. So in that case, what will happen, I can exactly pinpoint what is happening. So if I want to search by for that particular department, what is happening, I can bring the data for the whole company based on how many people copied data to S3. And then I can filter it down by the group or the user. Now, why AWS OpenSearch? So I have mentioned before that I have kept all my user IDs and all the other fields in the OpenSearch because I want to do full text search and all the other good things of the OpenSearch. But along with that, the vector DB is provided by now AWS. So why do I want to go outside and get it from the Quadrant or some other things? Yeah, definitely we need to go Quadrant, FAS or some other Pinecone if it is like outside AWS. But if my infrastructure is everything inside AWS, I can use the OpenSearch itself because it is all inside a secured VPC. And then it is a hybrid query we can do on that. We can, even after we do the metadata filtration and we get the records, after that you can leverage the other fields in the OpenSearch also to fine tune my queries. So these are all the benefits of OpenSearch is given over here. Now let's go like when I'm doing the embeddings also. So at that time I was using Bedrock because if you see the Bedrock has all of the models mostly like which we are using nowadays, right? So and every day it is getting updated and it is up to date. So I think instead of going to OpenAI and getting the models out of there, so why not get it from the Bedrock? And there's no GPU provisioning cost, no seamlessly flow with the other AWS resources. So you can hook up with the other resources and you don't have to pay any extra charges for that because you are already inside the AWS. Only cost is that the AWS embedding cost. And that is also very less. It is not free, but it is also very less. And also you can see the security. That is very important thing, right? So if you have built your infrastructure already, pen testing and everything is done, and you are inside a secure VPC and all the security groups and everything in place, So just doing that embedding thing is not going to give you open up a big hole for the security. So these are the benefits definitely for the Bedrock, and these are the operational cost. This is not directly related to the OpenSearch or AWS Bedrock and the insider threat detection, but this is a general thing which normally we get, like whenever we are developing any new system, we get an index drift, we get the embedding latency. So this is, I added this slide just as a knowledge base for you guys to find out if there is any problem. You need to find out like when you are developing the system. Okay, now let's go to the demo. So this is a system, and suppose I want to find out the top risky users in my system. This system is actually have like a 6 months worth of data. It don't have much because it is everything running in my local system. And I thought I'll not get the connection or something problem happened, so I didn't use the AWS thing. I just running it on my local system. So for example, if I want to find out what the risky users in, suppose August 2025, so it will bring you that the user here, there's only one user at that time was risky. So if you see here is green, that means if it will show you the activity on this side. And if you see here, it is actually accessing the CRM database, I think. One second, let me make this brighter. Yeah, he is accessing the CRM database, so that's fine. But now if you see these events, is a bulk export, customer list. So looks like maybe he need that one for his business, but still it is kind of a not a very good thing, right? Suddenly why is exporting so many customer information? Then if you see the next one is definitely a red because he's downloaded deal pipeline and finally uploaded to Dropbox. Definitely it is not a good idea that you are working, for example, in Amazon and suddenly using an outside Dropbox and uploading the documents. So definitely it is a risky. So now how I actually came up to this problem, right? I have this historical behavior, like every day whatever he is doing, it is getting embedded at night by that real-time streaming that's happening, right? It is using a prefect or Airflow or some kind of that thing, and it is getting all the data and then doing the embeddings in chunks and pushing it into the vector DB. And so by that way, when I'm in the 4th day, it is happening, I have all these previous things to correlate that what the bad thing is going on. So if he say that, okay, oh, by mistake I uploaded it. No, it is not by mistake. You are doing these bad things for quite a long time. Okay, so now I'm going to another query. Let's see. If I want to see the risky users for 2025, so I want to do a broader search. So now if you go down, you will find a lot of other peoples are also involved in that kind of activities. So suppose Maria Santos. Oh, she is also doing uploading fake invoice 500K. Sorry. So you can see like how his behavior is changing over a period of time. So you can see definitely that this kind of system is adding value to your corporate system. And if you feel like, okay, I am putting so much data into the vector DB, there's definitely a cost for that. And I want to put, instead of 3 months, I want to put a 6 months worth of data. So one thing you can do is that quantization of the vector database. So in that case, instead of like 32 bits, you can just go with 16 bits also. And you can put more data there. And when you are searching it back, you can do the metadata filtration like I discussed before, like for which user you particularly are interested for the text filtration. You can put that user, put that geolocations to narrow down your search. So in that case, you can get a much broader view of what is happening. Because there are also another use case that a user joined, but you don't have enough data for him, right? So statistics is all about data. So you don't have much data. So in that case, what you can do is that you can compare his data with his peers who is working in the system. And then you can get a visibility like, okay, he is like hooking up an external USB drive multiple times. But if you see his peers, nobody is doing that. And there is a company policy that you are not supposed to hook up any external drive to your machine. So by this, all this data and the historical behavior, you can easily correlate like what the bad thing is happening in the company. And then on top of that, as I mentioned, right, the OpenSearch database and the embeddings are also helping you to target the right audience, people, and what the problem is going on. Yeah, any questions? Yes. Yes, you can also keep that. So as I mentioned, when a new user joined in, when I'm comparing his data, so you have your ML model, which is actually comparing some baseline for that user, right? So I cannot compare that user with a sales user to a development user. But I should have some logic in my system, which is actually has build the baseline for that particular department or for the particular group. So the OpenSearch semantic search is bringing in all the high-level data. So it brings you a lump of data, and on top of that, you use that baseline to find out for that particular user how much it is deviating. And then you can do a standard deviation on top of that to find out over a period of 1 week or a 1 month, what is the deviation happening. Because you may have a risk score of 80%. If it reaches, then actually it is an anomaly. But sometimes I have seen a system that there is some behavior happens where the risk score is not reached, but still it is a problem. And he joined, his main intention is to take the company data and leave the company. So he joined within few weeks, he is copying the data and then finally planning to leave. So if I wait for the threshold to be reaching 80%, it will be too late. So I have to continuously see the deviation, what is happening from the normal baseline, and report early to the analyst dashboard, and let the analyst and the management decide like what exactly is happening and let them make action. So one more system that needs to be there with this insider thread is that whenever you are reporting a problem for a user, don't report his social security and the more like a proprietary information to the management. Because that also is not, because who knows like that dashboard is open up to whom, right? So always for insider threat, the problem reported to very high level in the management and then it flow down. Because it may happen that user didn't do anything bad. It is some problem in your system and it gone to his manager and his manager started discussing with his peers. So unnecessary chaos will be created in the system. So it is based on my experience with all this SIEM and all this environment security system development that now I know like even if it is a very high sophisticated system, but it needs to have a lot of guardrails. Yeah. Yes. Which information? So the OpenSearch database historical data is built from your own system. So you have your users in the system and they're using the system for quite a long time, right? So you have like everyday events that is happening. So you put this inside a system in your thing, right? So you, in the morning when you wake up, you open your machine, login, event happened. So it put in the OpenSearch database, not in the vector, but in the OpenSearch database as an event. So continuously, like when you are seeing here, right? So if you see here, these are all events. Like this is a node ID, but if you see here, these are all events happening. Continuously, these events are happening. So these events are going in your event fields in the OpenSearch database. And every night you are running a system which is taking these events, like thousands of these events, and vectorizing it every day. So whenever a user is coming in the analyst this dashboard and trying to search this, so it is first going to that vector database to find out the match for this one. Like I'm searching for users for 2025. So it knows that I need to search all the data for 2025 because it is a natural language query. From this, I am finding out the top risky users. This is the one that it needs to search, and then it needs to go and search for the year or the time period. Like if I put here 2025 August, then it will go and search for the August. But how it knows that it is 2025 August only, not the whole year? Because then it needs to, by the natural language, it finds out all the key things in this query, and based on this, it is creating the JSON objects, which is finally getting the guardrails to make sure it is going and passing the correct information to the system. Because you have to make sure that whatever your natural language giving over here is actually safe to go and push it into your system. The guardrail is there, right? So that, I answered your question, or? Yeah. Oh, yes. So, for example, whatever is I'm giving over here, I have a backend. I'm going a little bit more technical, if it is okay with you guys. So, when you are giving some query over here, it is using DSPY on the backend to see whatever the prompt is given, because my system prompt is given that whatever I give, you come out with a JSON output out of it. And I'm expecting this kind of JSON output out of it. We should have the user, it should have the device, and if any one of them is null, then I'm going with a more broader scope. Like suppose, for example, I say for 2025, so then it knows there is a user here. And then when it builds that JSON objects, it actually takes out each of these individual fields and create that object, and then it asks the next layer of this API, saying that, okay, I'm getting this one from the user. Is it valid? Is that not any PIA information? Is it not having vulnerability? Like now AWS is building the Bedrock guardrails. So similarly, you can hook up Bedrock guardrails to make sure it is not putting something bad. Now, when you are sure 100% that it is a good thing, and then you pass this JSON object down to the OpenSearch for query. Make sense?
I just want to let you know the Rafa starts now over at the HANA Auditorium. The rules are that you have to put something on social media about our AWS Community Day, and then you let them at the front desk know that you did it. Okay? Thank you.
Did I answer your question or no? Not really. Okay. Yes. Yeah, I'm passing LLM. Yeah. It is without LLM we cannot do that, right? Huh? I have a backend on I have backend DSPI.
What's that?
I have backend DSPY.
SQI.
Yeah. Because that's a thing, because it actually can play with the user inputs very well. Yeah. You can do even with the system prompt and user prompt also. Yeah.